Hello everyone. In this video, we are going to discuss the minor pathways of beta oxidation. In my previous video, I had started up with the beta oxidation of fatty acids and we discussed about the long chain fatty acids. Now we are going to study first of all the beta oxidation of very long chain fatty acids and the minor pathways of oxidation of fatty acids. Right? So we can simply say oxidation of fatty acids part 2. This we are going to study or focus on the beta oxidation of 𝗲𝗃𝗃𝗃 and the minor pathways. These include alpha oxidation and include omega oxidation. Right. Now, we all know that the oxidation of fatty acids always takes place in the fasting stage. Very important, and it is catabolic in action, or it's a catabolic process. Now, since it is a catabolic process, it has to take place in the mitochondrial matrix. Right. Now, the question is, we studied about SCFAs, which are short chain fatty acids, medium chain fatty acids, because when we are taking a diet rich in fat, we don't know whether we are having SCFAs or MCFAs, or we are having long chain fatty acids or very long chain fatty acids. This is medium chain, long chain, right? So, if we have to differentiate, we can simply say that these two does not require carnitine, or because they are very short, so automatically they will be transported to the mitochondria and immediately they will be oxidized. So, does not require carnitine. Right? If we talk about long chain fatty acids, they cannot move without carnitine. So, always require carnitine. So, this is the basic difference. Now, coming over to this, when the number of carbon atoms are more than 20, because long chain fatty acids may we can say stearic acid is there, palmitic acid is there. But what is the status of these VLCFAs? Means very long chain fatty acids. So, what happens is these VLCFAs, when the number of carbon atoms is more than 20, how they are oxidized, how they are transported. Now, this is a very interesting process. What happens in among VLCFAs, that first of all, their main site of oxidation is peroxisomes. Right? First of all, they will enter into the peroxisomes and then a rest of the oxidation will take place in the mitochondria. Now, the question is that how they are transported to the peroxisomes and then how they will come into the mitochondria. Okay. So, what happens here that to the peroxisomes, there are the different type of transporters which will help in the transportation of these into the peroxisomes. So, I can say that suppose if VLCFAs are here and say this is the peroxisomes. Now, what will happen is that these 𝗲𝗃 will enter into the peroxisomes. Now the main difference between 𝗲𝗃 oxidation, no carnitine is required here. Only transporter protein is required. Protein or transport protein. Coded by PTS gene. Now see, the moment this enters here, these 𝗲𝗃 will undergo degradation to form two products. Octenoyl-CoA. Octenoyl means 8 carbon atoms and acetyl coenzyme A. Right. So I can say that the oxidation of very long chain fatty acids first of all takes place in the peroxisomes. In the peroxisomes, the end product is octenoyl-CoA, which is having 8 carbon atoms, and acetyl coenzyme A, which is having 2 carbon atoms. Now this octenoyl-CoA will now enter in the mitochondria. Now see, octenoyl-CoA is having 8 carbon atoms. Medium chain fatty acids, no carnitine required. So it will immediately come and will be converted into acetyl coenzyme A. Right? So you can see by whatever we discussed about the beta oxidation of fatty acids, of long chain fatty acids in the mitochondria also. Now we have seen that 𝗲𝗃 oxidation also. Ultimately, the oxidation is taking place in the mitochondria. This is very important. So very long chain fatty acids produces octenoyl-CoA, which will enter into the mitochondria, and finished octenoyl-CoA will undergo simple oxidation. Right? Now what is the difference here? The most important point which we have to remember here is that here H2O2 is also produced. So we can say that first of all, end products of beta oxidation are octenoyl-CoA plus acetyl-CoA, and second important thing here is that H2O2 is produced. Very important, because we are dealing with the peroxisomes. So these are the two main differences of the oxidation of 𝗲𝗃 and LCFAs, and no carnitine is required. In fact, a transporter protein is required. So this is the oxidation of 𝗲𝗃. Then after this, then we come over to the minor pathways of oxidation. So minor pathways they include alpha oxidation first of all. Alpha oxidation. Now as the name suggests, alpha oxidation is again along the alpha carbon atom. What is alpha carbon atom? Just adjacent to the functional group. So we can say that break on the carbon atom adjacent to the functional group. Right. So if I say this is a fatty acid. So alpha oxidation will be here. Always remember, along the first carbon atom. And basically it takes place in the products which are rich in phytanic acid. So I can say that phytanic acid or phytanoyl-CoA is the substrate here. Undergoes alpha oxidation. Right. And this phytanoyl-CoA is rich in green leafy vegetables and milk also. In some books it is mentioned that goat's milk consists of phytanic acid. In milk, or I will just write goat's milk. Right. So we can say that the green leafy vegetables or goat's milk, which is rich in phytanic acid, it has to undergo alpha oxidation first. Once alpha oxidation is there, again it is going to form some soluble compounds, then again it will undergo beta oxidation. Now the question is, what is the site? So if we talk about the site of alpha oxidation, it is mainly in the endoplasmic reticulum and in the peroxisomes. Right. And then the third one is omega oxidation. Now, what is omega oxidation? We know that the farthest carbon atom. So, you can say oxidation at the farthest carbon atom. Carbon atom. So, we can say that if suppose this is a fatty acid, this will undergo oxidation and it will always lead to dicarboxylic acids. Right. And if we talk about the site of omega oxidation, the site of omega oxidation is microsomes, SER. Okay. So these are the alternative pathway of oxidation of fatty acids. So major pathway we can say is beta oxidation. The minor pathways are alpha oxidation and omega oxidation. And under beta oxidation also, if we see clearly, short chain and medium chain fatty acids will not require any carnitine for the transport. Long chain fatty acids will require carnitine for the transport. And very long chain fatty acids will simply, with the help of a transporter, will be transported to the peroxisomes where they will be degraded to form octanoyl-CoA and acetyl-CoA. And this octanoyl-CoA automatically will be transported back to mitochondria, where again, since being a short chain fatty acid or medium chain fatty acid, you can say 8 carbon atoms are there, it does not require carnitine, and it will be completely dismantled to form acetyl-coenzyme A. So always remember, the oxidation will take place in the fasting stage. It's a catabolic process. Principally, it occurs in the mitochondria, it occurs in the peroxisomes also, and it occurs in the endoplasmic reticulum also. But the principal organelle is the mitochondria. Okay, so this is all about the video on the beta oxidation of fatty acids, minor as well as major pathways. So in the next video, we will be studying about the metabolic errors associated with the oxidation of fatty acids. Thank you so much.